Howdy folks, I've had this book for quite some time now. It's actually a Virginia Geological Survey, bulletin number 17, and it's titled Manganese Deposits of the West Foot of the Blue Ridge, Virginia. It's written by Stoss, Meiser, Katz, and Hewitt, and it's actually quite an old publication. It actually has a date of 1919. So last year, which was 2019, I thought is a 100-year anniversary of this publication to actually try to find one of these deposits, since I'm actually in the area. Now these folks did a really good job of actually documenting all these deposits here, and they actually came to the area, they actually visited and tried to find every one of these deposits that were reported. Not only did they look for them, some of them, a few they couldn't find, some of them were just so, there was almost no sign left of them. I mean, even 100 years ago they were already grown over and filled in or whatever. But they put a whole detailed amount of information, including exactly what was actually produced at these locations as far as tons or you know, how much was hauled out and what they found, or if it was not commercially developed or what. So there was one I was able to actually find, and so I thought that was kind of neat. And it wasn't a mine as much as what they call a prospect. And basically it was a hillside where you could tell they dug out, and the topsoil was missing, and the vegetation was a lot different than the surrounding natural vegetation there, a lot more scrubbier sort of stuff because the topsoil wasn't there. And so I looked around and I was able to find some material that I thought that might contain manganese. So I want to go through and test some stuff that I found here for manganese and see what we get. Let me show you what I found. Here are two materials right from the prospect area. Now, actually, the manganese minerals that they listed in the book included silomelane, which actually could contain barium, and some references say it definitely contains barium. Others include manganite and also pyrolusite, and also something called wad, which is kind of a combination of a secondary or more a deposit of conglomerated material. This first one is, I think it's the wad. It's a very fine grain, looks like sedimentary material that from the manganese material that was there that formed. Now the second material here is actually, it looks a little different in color. The other stuff's more gray. This is maybe blacker. It's hard to tell because of the stains on the outside. But this one has actually, instead of just being grainy, this actually has some very small botryoidal sort of features to it if you look at it under magnification, and also a couple little shiny areas here. And then the third material I found is here, and this is a coating that was on a rock, and you see it's actually well botryoidal, very shiny in this, and more crystalline, as you see on the edge here. And there's also some thinner spots that were between some cracks and crevices. But this was not at the prospect. This was about in the same area, but maybe a mile away, maybe less. But anyways, so we're going to give those a try. I went through all my books and references looking for different methods and tests and indications for manganese. And I found 4 that I'd like to try. One is the borax bead method, which is really straightforward. If you make a borax bead with the mineral, it should give you a nice deep red or actually kind of violet sort of color. Very simple to do, so we'll give that a try. The other method is doing a fusion with a soda nitrate flux. You mix 4 parts of sodium carbonate with 1 part of potassium nitrate. You mix that with the mineral and you melt it together into a fusion, and that fusion should have a bluish green color to it. And if it does, that's an indication for manganese. The third method is a permanganate method, and that actually uses the fusion. A lot of the manganese minerals do not go into solution well unless you do a fusion first. So we'll take that fusion, we'll dissolve what we can out of it with water, and then we'll acidify that, and if we get a purplish sort of permanganate color, that's an indication of manganese. So that sounds not too difficult to do either. The last one is a little bit more off the wall. I've only seen it on one reference, and that's a book by Donald Peck, and I don't know the name of it. It has something to do with the mineral identification in the title. And you make a indicator paper with filter paper and a solution that's predominantly silver nitrate, and that, when you put a solution of the mineral on there, it should turn dark if there's manganese. So we'll give that a try too and see if that works. So hopefully out of those four methods we'll get a couple that work. Let's go ahead and get started. Basically what I have here, these are the powdered minerals. Here the three, the wad, the more botryoidal stuff, and this coating. And I also have some manganese oxide chemical, so this will be a positive, and I also have a blank that will do a blank. And I've actually taken some of these materials and mixed it with the flux, the soda potassium nitrate flux in each of these. So we're going to go ahead and do borax beads on these, and a blank bead, and then we're going to do the fusions with these and see what kind of results we get. Let's give her a whirl. Alright, here's a clear bead just from the plain borax, so you see that the blank is good. Now we're going to try to put a little speck of mineral on here. Actually, this is from the coating. We're going to get it warm first so it sticks. Alright, I got my reading glasses, and it looks like I have a speck or two of material on there. Okay, we're getting a little bit of color, but I don't have much on there. Alright, I spared you the trouble of having to watch me make all the beads, but from my experience before, I found that the manganese is very sensitive to the amount that you put in. You can get a very black bead very quickly. You have to have just the right amount of material in there to get the color without it becoming either too light or too dark. But I did find something quite interesting, so let's take a look at the beads. I did the blank, but I don't have and it came out clear, so I didn't save any of the blank beads or beads that I cleared the wire from. But let's go all the way over to the manganese dioxide that was a known, that we know was a chemical, and I actually did two different beads. One that was a little bit lighter, and one that actually has more material in it, because it gets dark so quick. So I don't know how well this is going to come up on camera, but this definitely has kind of a reddish, purplish sort of color to it. Not real dark. It's pretty clear. Let's see. I don't know what that's going to do for you on the camera, but hopefully you can see that. And here's the dark bead. It's almost black, but you can see kind of a ruby color to it. Let's see what that looks like in the light. Yeah, hopefully you can see the red color. So that worked out just fine. So we found the manganese there, no sweat. So let's go ahead and look at our samples here. So the first one was this wad that was a uniform sort of granular material, and I don't know if you can see this here, but that looks very similar. It's a very light reddish purplish color, very similar to the known. And the other one's trying to get away here. And this is pretty dark, but especially in the light it starts getting that oh, I call it kind of a ruby color to it. So, pretty neat. We did find manganese in that material. The next one was this stuff that's kind of has these real small botryoidal things, but still pretty massive, and a little different color. And there we got about the same situation here. Oh, these beads are hard to get. This one was pretty light, but it has the same tinge to it. And this one's darker. But definitely has that ruby color, so that's kind of cool too. So we found manganese in both of those materials that we found at the mine. Now this last material I found away from the mine, but being botryoidal like that, and you know, that black color, I'm thinking that's manganese too. So I did a bead, and boy, I added a lot of material, and it never really got dark. And it actually kind of was sort of orange when it was hot and cooling down, but when it cooled down it actually got really light, and I had to put a lot of material in it. This is one of the lighter ones, and I don't know if you can see it, but it actually had a yellowish color hot, and now it's kind of greenish. And here's one that's there are two of them that are quite a bit darker. And those definitely have a greenish hue to them, and not nearly as opaque. In fact, you can see through that pretty easy. So the beads here are definitely different than the manganese known and the other two manganese materials that we got near the prospect. Even though this was in the same area, and boy, being botryoidal like that, I thought it was a really nice sample of a manganese mineral. But based on the bead, that looks like iron to me. A lot of iron beads. I get this, oh boy, I get this green bead just like that, yellowish green. So that's looking like iron. Now the other thing I noticed too, and I went back and actually, you know, here's some of the materials. These were the manganese, the wad, and the more massive botryoidal. And here's that coating, even though it's black. And I went back to double check this because I wasn't sure what was going on. I thought I might have had a lot of the brown base rock in there, but actually when I take that black coating and crush it up, that's effectively doing a streak test in it, I get kind of a reddish brown. So, being a different color, having that reddish color for the powder, which is essentially the streak, and having the greenish bead, this really, and the botryoidal form and all that, that just really points to that being hematite and not manganese at all. So that's kind of interesting. It wasn't in the exact same area. Like I said, it was about a mile away, and these two pieces were found in the area of the prospect. So that's kind of cool. I'm very surprised at that. I'm going to go ahead and do these fusions now. It's actually a flux with soda, 4 parts soda, 1 part potassium nitrate mixed with some of the powder material. I'm just doing it in on some porcelain. This is actually a broken crucible. So actually the first one is a blank. I don't know if you can see, it's melting into a blob. I actually used a flame to kind of push it together into one mass. Just make sure it's all melted well. That looks pretty good to me. Okay, I have the 5 fusions done. Once again on the porcelain. The first one is the blank, and it just came out white as expected. I did add quite a bit of mineral matter to this stuff. Well, this next one is from the what looks to be wad, And I don't know if it comes up on the camera or not, but if there's manganese, there should be a bluish green color to it. And I added a lot of the minerals, so they come out pretty dark. But there's definitely a right on this upper edge here and on the back edge there, definitely I would call it kind of a turquoise sort of color, maybe more bluish. So it's looking like there's manganese there. The second one is the silomelane, I'm not sure how to pronounce that sort of material. And that definitely has kind of a almost iridescent sort of bluish green coating on the top. The next one is this coating that was on the rock that actually gave us the yellow-green sort of borax beads, and can't see any blue or green sort of tinges there, so no manganese. Once again, that's quite a surprise to me. And the last one is actually the manganese dioxide that's a known, and I'm not sure what the glare is, but that definitely has a blue-greenish cast to it. Interesting enough that matches the bead, which isn't, I guess, too surprising. We got a manganese positive here, manganese positive here, and a manganese positive for the known, which we would expect. I took all the fusions off of the porcelain and ground them up in a mortar and pestle. And I thought I'd show you what the powders look like. The blank is still white. This one that actually had the least blue to it, but definitely a blue on the surface, actually has quite a bit of a blue color to it. And that was from the wad sort of material. This that had a definite blue-green on the outside is more of a. It was kind of bluish when you're grinding it, but it faded to kind of more of a gray with just maybe a hint of blue. This one's brown. Didn't have any blue to begin with. And the manganese dioxide, the known sample, was very blue when I started breaking it up. But since then, it's kind of more of a gray with maybe a blue tinge here. So, anyways, just for a point of reference. All right, I had a camera malfunction, but I did take some of the fused material and dissolved it in a little bit of water and poured off the liquid. They were all kind of, the blank was perfectly clear. The wad actually had a distinct green color to the liquid. The botryoidal material was pretty much clear and maybe a little bit of a yellow. The coating, which didn't show manganese before, definitely had a yellow color, and the manganese dioxide actually was kind of clear too, maybe a little bit of a yellowish. Upon adding acetic acid, the material, the wad, actually turned a purplish color. It's turning more of a brown now, but it definitely turned kind of a reddish purple for a permanganate sort of manganese color. The others really didn't do much of anything. The coating that was a little bit yellow was still yellow. And the other ones that were clear, you wouldn't expect them to suddenly change color, but anyways. So I'm not sure what the deal is. We definitely got blue colors on the fusions of the manganese dioxide known, and we'd expect to definitely get a reaction further with the test. Maybe I didn't dissolve enough of the fusion in the water, but it didn't seem to be quite as consistent as the borax bead or just the color of the fusion itself. I made this, I guess you'd call it an indicator paper, from the procedure in Donald Peck's book about mineral identification, and basically taking 5 or 6 drops of silver nitrate solution and concentrating it down, and then adding a drop of ammonium hydroxide and putting it on the filter paper. So I'm going to go ahead and put a drop. It's supposed to turn dark if there's manganese. This is the blank material. All right. In summary, I learned quite a bit from this project. As far as the testing methods go, I got a couple that worked really well. The borax bead was really easy to do and gave us a nice red-violet sort of bead indicating manganese. And the fusion with the soda nitrate flux worked well too and gave us a nice bluish green coating on it. It wasn't quite as spectacular or apparent as the borax bead, but it worked well and was consistent with the samples. The third method didn't work out very well. That was the permanganate method, but I think I could get that to work out. It did work for one of the samples, but I think if I use more of the flux to dissolve the material, and also there's a lot of different variations in the method. If I worked on that and got it nailed down, I think I could get something that worked really well. The last method I think I would forget about, that was the silver nitrate indicator paper, and I probably could get that to work too, but the other methods are so simple, and silver nitrate is a little bit expensive. There's no real need to do that. Secondly, what I learned from here was that I was able to confirm the manganese and that I found the prospect that I was looking for. So that was really cool. I've been kind of hunting that down for quite some time, and now that I know geographically I was in the right spot, and as far as testing and chemically I could determine that that was manganese, so I feel confident that I actually found it and that I accomplished my goal. So that was kind of neat. And lastly, as far as the minerals themselves, the book actually says that a lot of these manganese oxides and hydroxides or hydrates are kind of hard to differentiate without some real in-depth analysis. And sounds like he didn't even bother, but the one material was definitely a wad that was more of a sedimentary conglomerate of the material, and the other material was a silomelane, which matched what they had in the book and the descriptions, so I feel pretty good about that. But the third one that I thought was a manganese mineral, a little bit more crystalline, wasn't, and that really surprised me, because that was the first one that I found, and I thought, oh great, here's this black coating, kind of botryoidal. Surprised the heck out of me that it didn't contain any manganese at all, so, and that it was hematite. But it was very apparent when I started testing it. Looking at it, no, but upon doing the testing, it was very apparent that that did not contain manganese, and it was not the manganese mineral. So that was really cool that I was able to find that out when it seemed so obvious that it was a manganese material. So that really kind of confirms the usefulness of some of the testing. So anyways, if you lasted this long in the video, congratulations, because I know it's a long one. So you really must have a lot of mineral fortitude to make it this long. I might actually do another video about the prospect itself and some video footage out in the field, which I don't have. I have a few pictures and things like that, but I could give a lot more details on you know, what it looks like and how I found it and things like that. So, but that's for another day. So anyways, thanks for watching, and happy mineral identification.